Hello students, hope all of you are fine. Today I will be discussing a direct method of solving linear algebraic equations. Direct means you will get the exact value of the unknown variables. Okay, so our method will be Gauss-Jordan method. In the last class we have seen the Gauss elimination method where we have converting. Our main objective was to convert the A part of the augmented matrix to an upper triangular form. Okay, that means the elements below the diagonal element should be 0. Okay, that was the Gauss elimination method. Today, in this method, what you need to do is you need to change that same A to an identity matrix. That means you need to change the A part to an identity matrix. That means identity matrix, or you can say diagonal matrix also. You can change it to diagonal matrix also. So diagonal matrix means only diagonal elements should be present, that means should be non-zero, other elements should be 0. And identity matrix is that it is a diagonal matrix where the diagonal elements carries a weight of 1. That means the value of the diagonal elements are 1. So this is the difference of these two methods. This is a modified version of Gauss elimination method. Okay, so before explaining this method, I want to discuss something which I missed in the last video. It's known as this thing is the pivotal concept. Pivotal means there will be, if I consider 3 cross 3 matrix, there will be 3 elements which are playing a major role in converting my A part of the conjugated augmented matrix, that is a C, to an upper triangular form. Because those 3 elements are playing the main role, pivotal role. Okay, so let's see. So suppose this is an arbitrary A matrix. First element, what you call, is A11, first column, first row. So this is your first element. This element will play a major role. That is, this element will be a pivotal element. Why? Because this element is playing a pivotal element in making these 2 elements underneath 0. To make these 2 elements 0, this guy is playing a pivotal role. Okay, and there are other 2 pivotal elements, A221 and A332. A221 means 22 means how much? Second row, second column. So this element, and I have written 1. 1 means it is the modified form of this one, and 1 means just after first set of row operations what you got, that means this one, second row, second column, will be your pivotal element, A221. Because now this guy will play a major role, pivotal role in making this element 0. Because ultimately we need to change this to an upper triangular form. So to make this element 0, this guy is playing a major role, pivotal role. Fine. And another one is A332. A332 means after this state, whatever remains as a last element of A, if I consider 3 cross 3 matrix, will be your A332, third row, third column, and since after 2 steps, so it is 2. So this guy will play a pivotal role in giving you the value of the variable, last variable you can say. So this is also a major element. Main thing I want to highlight here is these 3 elements can't be 0. That means they should be non-zero. If they become 0, what you need to do is you need to exchange the rows. You need to swap the rows. Okay, so if you swap the rows, it may happen that now the pivotal element, that means the element at that position become non-zero. Okay, now they can play the pivotal role from there. Okay, so remember one thing, the pivotal element should be non-zero. Fine. And if they become 0, the matrix will become singular, you will not get the solution. Fine. So this is what I want to mentioned here. Now let's come back to Gauss Jordon method. So this is a problem which I have chosen out here. 2x1 plus 2x2 plus 4x is 18, x1 plus x2 plus 2x3 is 13, 3x1 plus x2 plus 3x3 is equal to 14. So this is the three set of equations, three unknown variables, x1, x2 and x3. You need to find out x1, x2 and x3. Okay, so what I have done here is I have simplified this first equation. See, I can take 2 common, right? So if I divide both sides by 2, I will get this x1 plus x2 plus 2x3 is equal to 9. This is simply, I have just simplified it. Now the process is same. My augmented matrix is A and B. It consists of the coefficient part and the B part. A is this, and I've chosen this one. So 1, 1, 2, 1, 1, 2, 1, 3, 2, 1, 3, 2, 3, 1, 1, 3, 3, 1, 3. And B is 9, 13, 14. 9, 13, 14. So if we concatenate, you will get this one. This is your A part, this is B part. Now, as I told you, our objective is to make this A part an identity matrix. That means I want to make this 1, 0, 0, 0, 1, 0, 1, 0, 0. And whatever remains after this dotted line, as I say, it's called a mirror, will be your simply the solution. We'll give the x1, x2 and x3. Whatever remains here is your x1, whatever remains here is x2, whatever remains here is x3. You can ask me, sir, generally we write the A and B side by side, right? So how can you write x here? Okay, then check out here. Ax is equal to B, right? We know that because A into x is basically this one and B means this one. So x is equal to B, you can write from that problem on directly. Now your new A, this is your new A, right? If I write, if this becomes an identity matrix, then 1, 0, 0, 0, 1, 0, 0, 0, 1, and x1 is x1, next matrix is x1, x2 and x3. B is, suppose if I write b1, b2 and b3, then if you perform the multiplication operation, you will get x1 is equal to b1, x is equal to b2, x is equal to b3. Okay, that's why I have written here x1, x2 and x3. Fine. So I hope this part is clear. Now what you need to do is, you need to reach this goal. Okay, so let's see. What I have done here is, in the second part, I have performed this R2 minus R1 operation. So if I do that, R2 minus R1 means this one I have subtracted directly to make this one 0. So 1 minus 1 is how much? Is 0. 3 minus 1 is how much? It's 2. 2 minus 2 is 0. 13 minus 9 is 4. Okay. And other rows remains the same. Another operation I am doing here is, which involves R3 and R1. R3 minus 3R1, and which one I want to modify is R3. So R3 I need to modify. So if I do that, so 3 minus 3 into R1, 3 minus 3 into R1, 3 minus 3 into 1 is how much? 3. So 3 minus 3 is how much? 0. Is 0. So now 1 minus 3 into 1, how much? Minus 2. 3 minus 3 into 2, how much? 6. So 3 minus 6 is how much? Minus 3. Now 14 minus 9 into 3 is 27. So 14 minus 27 is how much? Minus 13. Okay, so this much I have done. So what is the gain? After this operation, I have made these two elements 0. And in both the cases, see, R1 is playing a major role. Okay, so this is the first part. Now see, this second row becomes 0, 1, 0. That means it becomes a part of an identity matrix. But this should be 0, 0, 1, and this should be 1, 0, 0. This should be 1, 0, 0. This should be 0, 0, 1. So if I want to do that, I am doing these two operations. See, what I am doing is, first here is R1 minus R2. R1 minus R2, and I am changing the first row. R1 minus R2 means this one. So 1 minus 0 is how much? Is 1. 1 minus 1 is how much? Is 0. So 2 minus 0 is 2. 9 minus 2 is 7. Done. Other things remain the same. And at the same time, I am performing this operation. So this is basically not 1, it is basically your 2. Okay. Now what I am doing here is I am doing this operation. R3 is equal to R3 plus 2R2. So if I do that, simply I am adding this 2 with a multiplier of 2. So 0 plus 2 into 0 is how much? 0. So 0. So this one is 2. Okay, so sorry, minus 2. Minus 2 and it is 2 into 1. So minus 2 plus 2 is how much? 0. Then minus 3 is 0. So no function of the multiplier. So minus 3 will remain as it is. And this minus 3 plus 2 into R to 4. That is minus 3 plus 2 into this 4. So minus 3 plus 4 is how much? Minus 9. Fine. So this is what I got. Now what I have done is here is 0, 0, minus 3, 9. So what I have done, I have divided this row by minus 3. Why? Why have I divided by minus 3? To make this one, this element 1. Because if I want to make this matrix identity matrix, I need to make this element 1. So that's why I am dividing it by minus 3. Fine. So 0, 0, 1 now you will get. Okay. So this part is over. Now the thing remains is this 2 row becomes like an identity matrix, but this one is still not done. You need to make this element 0. Right? You need to make this element 0. So our last part is to make this element 0. Okay. So what I am doing here is I am changing, obviously I need to change the first row, and operation I am doing is R1 minus 2R3. R1 minus 2 into R3. 2 into minus R3. So what I got? Here is 1, 0. And now see here is 2 minus 2 into 1 is how much? 2. So 2 minus 2 is how much? 0. So this becomes 0. And this becomes 7 minus 2 into R3 is 6, right? 2 into 3 is 6. So 7 minus 6 is how much? 1. Okay, so this is what you got. And I haven't changed anything, the other rows, because they are already become a part of an identity matrix. So basically I told you whatever remains after the dotted line, after changing this A part to an identity matrix, will be your solution. So this is 1, 2 and 3. So this is basically your x1, this is your basically x2, this is basically your x3. So if you want to check whether these values are correct or not, you can put it to any equation. I have chosen here the second equation. So x1 is how much? Is 1, x2 is 2, x3 is 3. So 1 plus 3 into 2 how much? 6. 2 into 3 is how much? 6. So 1 plus 6 plus 6 is how much? 13. 13. That means our solution is perfectly correct. Okay. So this is basically your Gauss-Jordon method. Basically you need to change the A part to an identity matrix, or you can change it to a diagonal matrix also. So remember, if you change it to a diagonal elements, and if you are not changing that diagonal elements to 1, what you need to do is simply you need to apply x is equal to b again. So then what you will get? You will get some values of x, and you need to make you need to divide with that multiplier, whatever will remain as in the diagonal elements. Suppose in the diagonal elements, if it remains 2, then if you want to find the value of suppose x1, x2 and x3, you need to divide it by 2. Okay. So simply if you change it to an identity matrix, you will get the solution directly. If you change it to a diagonal matrix, then you need to simply do one more step, x plus b. A is now your new A part, and b will be your modified part. And then if you multiply it, you will get some again 3 equations. From 3 equations you will see again by back substitution you will get the x1, x2, x3 values. But if it is possible, if you can do this, means if you can change it to an identity matrix directly, then it will give the solution directly. You need not to perform the operation, means x is equal to b and then again solving again back substitution is not required in that case. Okay, I hope you have understood. If you have any problem, you can call me or WhatsApp me. Stay safe. Thank you.